Hello, I'm Naning Jin. This is one video for KV7006 machine learning module. Today we are going to see K nearest neighborhood, which is one method of classification. So we start with basic understanding what is supervised learning and what is unsupervised learning. In my overview, I have already mentioned that supervised learning in simple way is which contains data which have class label. So, for example, you're in undergraduate first year, you're in the class of undergraduate second year, final year, and your MSc and the PhD. So these are classes labeled in order to group people in different groups, right? So we know first year are group of students, second year are group of students, which this variable itself can differentiate student, for example. So that is basic classification. And the gender, female, male are classes, okay? And these kind of things, normally we have one variable which is we call target. Also is the same way, same meaning of class, okay? And other variables used to describe the data, normally we call features. For example, if, for example, I know the modules you are taken, for example, I know you are taken module start with 5, module number, I know you're in the first year undergraduate module. So if you are doing your module has class 7, start with 7, we know you're in MSc module. So, and then we know your class is MSc. On the other hand, if we don't know the year you belong to, we don't know your first year student, we don't know your second year student, we don't have that class label data or target data, then that become unsupervised learning. So we will use different way to group students together. Okay, so basically in very, very simple way, supervised and unsupervised learning, the key difference is if we have a variable, which is a class of these data records. Okay, to give you example, to clarify that, I'm going to give you a very simple example, which only contains one feature, which is the size, cm. Another one is the label or class, okay? So we have 3 class values in this diagram. So this is classification. Okay, so we have historic data which have one features to describe the object. For example, we have lemon, which dimension 30, apple dimension 60, and melon dimension 120. Okay, so this data have been given like a fruit. So I have a box of fruit. So human expert already labeled it. Okay, if I have measured this fruit, which have 30 cm, I know it's lemon. Okay, so that's historic data for training we have already have for you to learn. And then you build a model, and then you will apply that model to new data which hasn't yet got class label, or their class label is unknown. So based on historic knowledge, we extract a model, and then that model we apply to classify new object which without class label. Okay, so that is the key concept of classification problem. Okay, so now I have a new fruit coming, which is I measured 55. So are they apple or are they lemon? So just use our common sense, right? I think it's more likely it's apple, because it's closer to 60 and rather than 30 or 120. Okay, so this is the principle we are going to use for the methods of classification. Okay, that is the reason, fundamental understanding reason we measure the distance of the variable on distance on cm, size of the fruit. Okay, so next step is I give you a diagram on 2-dimensional. So now we are going to have two variables. For example, one is cm, one is another one, for example. Okay, so and then we know on current diagram there are two dots. One is red, one is blue. So there are two classes here. One is red, one is blue. Okay, so there are in total 9 objects, which is historic data. Just like we have seen about the fruit, they have already been given a class. So we know that, I don't know if you can see my mouse, the top one, the red one, have certain x value, the top one has certain y value. Okay, and this one also have y value and x value. So these are 2-dimensional variable with class as a third column in your data record. So for example, this is the first column of data is x, a second column is y, and then you have another column which is called class. So in your database, I think most of us have already learned relational database. So that is a historic data which has been given the label in the class. So we know red and blue. Okay, so we build a model based on this, which is classification machine learning method we are going to learn later. And then we build a model, and then we're going to apply. Okay, so now I got a new object come in. It's the black one, square in the square, which has no class label. But do you think this is red class or blue class? Think about it. And how would you able to classify it? Just in your common sense, how would you think? It will be closer to red or closer to blue? When we say close, actually we measure the distance, right? So we are trying to measure how far the square is from the two red dots, which is closest to it. And we also try to find 2 dots, for example, the blue color, which is closest to it. So, end of the day, do you think is blue and red based on our calculation? Okay, so we move on. So you got the understanding principles. So in this time, we already know their value. For example, the value of the x and the value of y. So what shall we do? So basically, this method we mentioned is k-nearest neighborhood. So what is the k? I come back to here, k, okay? So here we already have 2 clauses, okay? So the neighborhood means the object around the black square, which we don't know the class. So in previous example, I mentioned 2 dots. So in that case, k equal to 2, okay? But you can imagine k equal to 3 in this condition. So I need to measure the distance of the square one, the black one, to the red one, which is closest to them. 3 of red one, which is close to the black dot, and also 3 blue ones, which is closest to the dot. You can see by this diagram that 3 blue ones altogether closer to the black one rather than the 3 red one. Although 3 red one has 2 of them closer to the black square. Okay, I make it simple. If we only look the distance of the square one to 2 red dots and to 2 blue dots, it looks like, just by visualization, they are closer to red one, right? However, if we look at 3 objects, so how distance between the black one to 3 blue ones and the black one to 3 red ones is look like the average distance between the square one is closer to blue rather than to red. Now we think k equals 5, so we don't have 5 for red at the moment. And then you can see, depend on the k value, sometimes if they are in the border, the k value changes, they probably classify to different classes. Okay, in summary, this comes to a more systematic understanding of the algorithm. So we have to have training data with class label in order to use to classify new objects. Distance metric is key. Just by visualization, we know if they're closer to something, they're probably in the same class. Okay, and the value of k, as we say, which may make differences on which object belongs to, especially in the border. Okay, the output is we are going to tell people the black square in loss diagram is belong to blue group or red group. Okay, so that is output algorithm. So in the middle, there's something called procedure, normally written in pseudocode. So first step is to compute the distance training example, as we already did in the last slide, and identify key nearest neighborhood. So we have seen 2 and 3, k equals to different value makes sense. Okay, and take a majority vote of class label among the key nearest neighborhoods. So there's a mechanism called voting. So for example, I have 5 objects. So maybe I come back to last slide to explain the voting mechanism. So we take the example k equal to 3. So I measure this distance, I measure distance, and measure distance, and measure this distance, and measure distance, and measure distance. So, and then we use the voting mechanism to see how many more number of k, like 3, how many more samples which close to the square than another group. And then we use majority voting to determine is blue or red. So this is a basic concept of the k nearest neighborhood. Now we move to more mathematical representation and understanding of this. So you can see on your right, there's one of methods to separate region in the k equals to 1 nearest neighborhood decision. Okay, and then in the left down, you would see distance measure on 2-dimensional. So I still keep the blue and the red as 2 different kind of classes. Okay, on your right hand, you will see different way to calculate distance. I know some of you already learned Euclid distance, Manhattan or city block distance. They are actually more than that. Or some of you in the last semester have already learned correlation and chi-square. Okay, and I think, yeah. Okay, so this diagram on your top left is based on k equal to 1. Okay, so in this diagram, we have no new object. The purpose of this diagram is to see the region of each sample. So you can see the grid area, we have made more than 10 objects, which have been classed as red. On your right hand side, you will see about 20 of records which have been classed as blue. And the dot in the middle is actually a record. Maybe this is a two-dimensional as well, x, y, okay? So we use this Vonomy method to define the region of the dots, okay? So you can see, just like a country map, different countries have their borders. So each region has a borders, okay? But on the, you can see the far end, several dots belong to one region. The reason is, if we look the area on your most left part on that diagram, you can see there are 3 red dots. Because if one new object falls within that region, it definitely is red. It's unlikely to be blue. Okay. So similarly, on your rightmost area, you can see we have 5 samples which is in the same region, because we know that they definitely blue. So if an object falls in this area, okay, we still know it is blue. But if it falls this area, we know it's red. So you may ask, how did we make this separation of different objects? So you can see, basically we draw a distance. If we look this one and this one, basically we draw distance. I'm not sure you can see, my mouse is moving, between them. So these are evenly separated between them, and also we have algorithm evenly separate between them, evenly separated between them. And we also can see about, the stress. You can imagine the stretch. Each have a certain power and evenly stretched by other objects. So the algorithm itself will be very, very complicated. The idea here is just for us to understand that. So they could be used for k equals to n, many kind of classification. K equals to 10, for example. So you may see each classes will have a region which, once your new object falls within that region, that belongs to that class. Okay, this just binary. So I hope that a little bit give you some idea of how this has been made it up. So just calculate the distance and find evenly divided between them, and at the same time I evenly divided between them and them. Okay, now we calculate distance. There are many ways to calculate distance. Okay, so I've got the one record which has x equals to this, y equal to this, the blue one, and also got the red one which has x, y value here. Okay, so how are we calculate the distance between them? Probably the city block here is a very traditional way to measure distance. So x, y, the difference between x, y, and we x red and blue, the distance on x, and then the distance on y. Okay. So just this x is not the same as this x. Okay, these two objects. Okay, x, y here is 2 dimensions of one object. So basically, in our case, we use xr, which is red, xb is blue, xb. So we calculate the difference on x, which is this one. We also calculate the distance in y, which is this one. Okay, and then there are several ways to work out the distance. So we don't have time to go through all this together. So maybe Euclid distance is quite traditional. This is just absolute difference between two objects, and I sum up in their dimension. So this has not been normalized or whatever. This one is also very traditional one, Euclid distance. And also we have learned correlation. Chi-square. So these are different ways to measure distance. So we probably have not got enough time to go through that throughout. But if you use different packages, you can specify which is your favorite distance measure in order to calculate the k-nearest neighborhood classification method. Thank you very much. So this is about k-nearest neighborhood. And I hope you got some idea about the algorithm, and we're going to use it in the workshop and the seminars. Thank you very much.